This video explains the EdgeGallery architecture. Edge computing empowers an intelligent society by becoming a great avenue for carriers, enterprises, and vendors to build new opportunities via best utilization of 5G. EdgeGallery is an open unified mutli-access edge computing platform, runs on heterogeneous edges, including Telco Edge and Enterprise Edge. The EdgeGallery is developed as a cloud-native platform, which runs on Kubernetes cluster, and manages both container and VM workloads. The platform has four major blocks: a developer portal, using which applications can be developed, or integrated, tested, packaged and certified. It facilitates a faster development, or integration of applications into the EdgeGallery platform, thereby reducing time to market. An application store is an edge application marketplace. Applications can be published from developer platform after certification test. Users can also upload applications directly to application store. MECM is MEC Manager. It includes MEO, which is MEC Orchestrator as part of central location, and MEPM, which is MEC Platform Manager, and can either be deployed centrally, or at edges. MEO is responsible for orchestrating applications to desired edges, and MEPM is responsible for deploying and carrying out lifecycle management of deployed applications. Finally, MEP, which is MEC Platform, runs at edge location, and provides a platform to run both VM and container-based edge applications. It provides a means for service registration and discovery for edge applications. Also, it includes open capabilities, data plane and functions like DNS, load balancer, application gateway, etc. EdgeGallery follows ETSI MEC standards and is in line with MEC 010 Part 1, MEC 010 Part 2 and MEC 011 specifications. EdgeGallery's MEC Orchestrator has direct mapping with ETSI MEC specified multi-access edge orchestrator. EdgeGallery MEPM performs application lifecycle management, rule and requirement management, and platform management, as specified by ETSI MEC Platform Manager. EdgeGallery provided MEP follows ETSI MEC 011 specifications, and support both MP1 and MP2 interfaces. There are two user scenarios supported by EdgeGallery. Scenario 1 is application integration, wherein an application vendor wanted to integrate his existing application with EdgeGallery. Second user scenario is application development, wherein an application developer wanted to leverage EdgeGallery provided capabilities to carry out his application development and deployment. Application integration, or application development in EdgeGallery, is performed in three phases, including application incubation, application repository, and application deployment. We'll first look into the application integration flow. As part of incubation, first step is to start an application integration project by providing necessary details about an application, as well as deployment-related artifacts. Next step is to do a sandbox test, wherein an application vendor can leverage EdgeGallery provided sandbox features to carry out application test. Next step is application packaging, wherein EdgeGallery facilitates auto-generation of application package. Then comes the certification test. For this, EdgeGallery provides a flexible means to manage test suites and test cases. Also, an application vendor can select some of these test suites against which he wants to certify his application. Upon successful certification, an application is released to an application store. At this phase, application has been successfully onboarded to an EdgeGallery provided application store. From application store, application can also be federated to a third-party or an operator application store. Next phase is application deployment. As part of this, MEC Application Orchestrator synchronizes application package from the App Store. MEC Application Orchestrator then instructs the MEP Manager to deploy an application. MEP Manager then deploy application to desired node and carries out lifecycle management of same. Now we'll look into the application development flow. As part of the incubation, the first step is to start an application development project by providing necessary details about an application, as well as deployment-related artifacts. Next step in this workflow is a service selection. EdgeGallery provides a rich set of platform services, which could be leveraged during an application development. All the later steps of application development are the same with application integration workflow. Now we will look into the architecture. EdgeGallery is a multi-access edge computing ecosystem, which has support for development, testing, upgrade, deployment and management of workload at the edge. The architecture includes components covering multiple stages including design, distribution and running. We'll look into each of them in details. On application development design stage, developer platform comes first. Application developers can develop or integrate applications into EdgeGallery using the developer platform. It provides SDK, plugins, sample code etc. for the application developers to easily build or integrate their applications. Using the application development capability design, applications can use existing capabilities, or add new capability. Both platform and applications can provide capabilities to other applications. Platform-provided capabilities includes both hardware and software capabilities, such as bandwidth, GPU, NPU, radio, location, AI/ML capabilities etc. And the application-provided capabilities are the one provided by EdgeGallery applications, through the ETSIMEC011 specification. Users can also upload images and other artifacts, build VM snapshots etc. in the developer platform for their applications. These images and other artifacts can be packaged together to form the application package. Platform provides a capability to deploy the application images on test nodes and debug the same before proceed further. Features such as web SSH, image optimizations are provided by developer platform. Sandbox and 5G environments provided by the platform can be leveraged by the applications to deploy and verify the applications. This provides a pre-verification and a development environment for the application developers. Profiles are software stack required to perform a specified task. Multiple components provided by the platform can be designed or arranged together to form a profile, which performs a predefined task, such as reading data from IoT devices, process it and store in DB. Using this platform feature, application developers can design or select a profile along with their application. The application testing and verification spans across multiple phases. Application Test Platform or ATP provides a flexible means to manage test scenarios, test suites and test cases. Administrator can dynamically add test scenarios, test suites, and test cases. User interface functions include selecting scenarios to be tested, visualizing the testing process, displaying test reports, contributing test cases, and uploading self-test reports. As part of application pipeline, ATP is used as an application certification platform. Application Design Platform takes care of deployment design and application packaging. Deployment package design is an offline entity, using which the EdgeGallery platform components can be designed and deployed. Application package design provides a capability for the users to design and develop applications, containing one or more capabilities provided by the platform, or third party. This provides a codeless application development feature to the application developers. Application repository comes next on application distribution stage. After the test by ATP, the application package can be published into application repository for persistence and distribution. Application monetization is a POC implementation, where the deployments are charged based on the duration and flavors. Application distribution helps in distributing the applications to multiple MECM orchestrators. Application experience provides an user interface for application users to share their experience about an application in terms of reviews and scores. The experience is beneficial while choosing on application. Application repository provides a persistent storage for the applications to store, distribute and retrieve the packages. Application repository can even support hierarchical deployment, wherein multiple operators can have their own application repositories, which sync the packages from a global repository. Application repository is designed to store even the API and other capabilities, and it is planned for future. The MEC orchestrator manages multiple edge clusters and applications in it. Application orchestrator is the one which is responsible for scheduling and orchestrating the applications on an edge node. Application package management downloads the applications from the application repository, and distributes the same to the edge nodes. Rule management handles the rules and requirements specified in the application packages, and makes necessary changes in the application after the deployment. It is crucial for an orchestrator to monitor the edges to take multiple decisions. The resource management takes care of handling this monitoring and management of the Edge node resources. EdgeGallery currently support OpenStack VM and Kubernetes-based workload deployment. A pluggable multi-VM management in the orchestrator helps in interacting with multiple VM layers. The module is designed as a pluggable architecture, wherein it can extend to any infrastructure in the future. A profile management in the orchestrator takes care of runtime management of the profiles deployed in the edges. This is planned in future release. Cloud Connectors enables the platform to share and leverage the capabilities of multiple public clouds. Intent-driven policy framework is also planned for future release. Edge platforms are deployed on edge clusters, which manages the container or VM workloads in the edge. An agent running along with the application ensures a smooth communication with the edge platform, such as gaining authentication token, registering or discovering capabilities, etc. Edge platform supports deployment of the WebAssembly applications as well. Edge autonomy is achieved using AppLCM and App Rule Manager. Application Lifecycle Management module in the Edge platform interacts with the MEC orchestrator, and act accordingly in the Edge, for the deployment and management of the application. Application Rule Management receives the rule and requirements from the orchestrator, and configures the same on the Edge platform. An API gateway in the MEP platform provides the authentication, authorization, rate limiting, etc. features to not only to the platform, but to the application services as well. Workload orchestration in the Edge are performed for containers, VM and WASM applications. Platform provides features such as security, auditing, load balancing, etc. for the applications. Capabilities are available in the Edge platform runtime to serve the applications. Capabilities are available as local and remote. Capabilities provided by the remote system which are not in the Edge are categorized as remote capabilities, and is planned for future. Local capabilities includes 5G network capability, third-party capabilities exposed via MEC 011 specifications, AI, profiles, ETSI, etc. Data plane provides a multi-network with isolations for the control and data to the workload deployment. Deterministic network and time-sensitive networks, SRI of, network programmable interfaces are planned for future release. In public services, user management take care of the identity management to the platform. The image management handles image storage and its distribution. External system management provides interfaces to other OSS, App Store, MEO, etc. Thank you for watching. For any questions, please reach us on main@edgegallery.groups.io.